Good afternoon, everybody. So my name is Amanda Southworth. I work at the University of Sheffield in the Material Science and Engineering Department as their outreach officer. I'm just going to go through some of the things you can do at home with a selection box or in school or wherever you can have this sort of equipment. So just to start us off, she says, if you can get it going, just to have a look at a couple of selection boxes, various different things you can do with various different ones. So I'm actually working with the Crunchy double-decker fudge whisper buttons selection box today, but there are some things you can do with the other smaller selection boxes you can get for about £1 in the shops. Particularly things like the Curly Whirly and the Chomp. I'll show you some things that I'll do with the little dairy milk bar that you can do with the Curly Whirly and have some comparison. So there's lots of different things we can do with selection boxes, various different variations that you can do with what is in there. So first of all, I just want to talk about why chocolate is the best material in the world. And I say this as an ex-teacher, as a teaching tool, it's incredible. First of all, it's cheap relatively to some of the other materials that you can get in the country and the world. It's relatively cheap and it's very varied. All the different aspects of materials that we look at undergraduate, postgraduate level is emulated in a chocolate bar in some description or other. It has all the properties we look for. So like you have your various different types of pure chocolate. So you have your dairy milk, your Aero, your Whispers, but you also have various different composites and various different laminations in there. For example, a Kit Kat Chunky is a great one. A Toffee Crisp, double-decker Snickers, all those different elements that you have that change the properties of chocolate and give us all those different lovely different aspects of chocolate that give us emulate those various different material properties that we often look at. And it's very easy to test at home. That's what we love about it. We can take it out to students, we can take it out to schools very easily, very cheaply, and really sort of sell the idea of testing materials in a really nice environment. And it means that people can eat it at the end of it. So how do we actually test in the lab? So we do actually use chocolate quite a lot in our labs. And we use various different machines in the labs and various different equipment. And these are the few of the ones that we can actually help you with. So the lab tests we do with our first years mainly is we use the Sharpie tester, tensile tester and hardness tester. And they do actually make their own chocolate bars. So this is in Sheffield in your first year. As an undergraduate material scientist, you would create your own chocolate bar and you would test it using these methods. Now, Sharpie tester is the ones in Sheffield are slightly larger than this one, but we have ones that are available to lend to schools throughout the Discover Materials family. So there's 10 of us across the country, so you can find your nearest one and get in touch with them and say, can we borrow your Sharpie tester? And it's all tabletop and very nicely to assemble, very easy to assemble. We also have a tensile tester, which I'll actually be using. I've got ours at home. And you can, again, borrow this to use, but that's to pull things apart. Sharpie test is to test hardness, so see if we can break it and how much force it takes to break it. Tensile test is to see how much strength it's got and how we can pull it apart. The hardness testing, we use that quite a lot, again, for sort of our stronger materials, but we can do like sort of an impact test with our various different materials that we use, including chocolate. We do this by changing temperatures, so often temperatures involved in these testings as well. So I'm going to show you a couple of demonstrations of this now. So we have, this is using our Sharpie tester, our existing kit Sharpie tester that all the universities have. And just to give you an example, so here's how we would test a Whisper, and this is all at room temperature, so no sort of special equipment required. So testing Whisper, hopefully this is, oh, hang on, that's the twirl. Don't know what quite happened there. So that's the twirl we've tested there. Let's see if the Kit Kat Chunky will work here. So as you can see, twirl, it's quite easy to break. Try again. Whereas the Kit Kat Chunky stopped it in its tracks. So that shows us both same material, both chocolate, but what difference, the thickness and various things like that. See if I can get the Whisper to try now. Oh, there we go. So the Whisper, again, pure chocolate, but just showing how we can use that to show the different properties. Each of these has a measurement on the top. So each Sharpie machine has a measuring device on the top to show the force either used to absorb, that's either absorbed by it or is used to break it. So various different Sharpie machines show various different things. So that's it at room temperature. So we like to use things at room temperature because it's easy to do. However, when we're in the lab, we like to sort of take it a little bit further, and we'll do things in with liquid nitrogen. So this is where we've taken chocolate bars, dipped them in liquid nitrogen, and then we've put them on the Sharpie machine. So that's this time I've taken the crunchy because the crunchy is quite impressive. So complete shattering of crunchy. Now, if it, like a lot of students think crunchy is really, really hard because they know the impact of eating it, and so it's quite hard to eat. It's like quite tough to bite into. So they expect a crunchy to be really, really strong. Difference with strength and hardness. So sometimes it's worth having a look at that. Twirls, again, we're using the twirl. Again, that shattering is really sort of quite impactful when you show a student what happens. And the Kit Kat chunk, if you remember from the room temperature one, very, very hard, very strong, very difficult to break. Whereas if we put it in liquid nitrogen, it goes straight through it. Not quite as dynamic as the other two, but equally as effective in demonstrating what can happen with a change in temperature. So that's sort of what we can do with various different ones in the lab and with sort of, as I say, specialist equipment. But how can we do this at home? So I've got various different things here that I've picked up from the house. So digital scales, really, really important for sort of measuring things, really good for showing comparisons. So at sort of key stage 2, various different things, not so much sort of working out using the mathematics, but you could extend it if you're key stage 3, key stage 4, but really good for sort of comparison. A ruler, always useful, very important. 2 glasses. Now I'll explain how we use these later, but I've got 2 small glasses that I can use, or 2 supports. They could be anything, just as long as they're the same height to for bending tests. A mug and some hot water. I'm going to show you what we'd use that for later, and some weights as well. So any sort of regular weights often can be found in a science class in a school, but even if you've got sort of consistent weights, sometimes bags of sugar can be really good, or using apples, so something that's got a consistent that you've got multiples of. And what we can do we can do various tests at home, and I'm going to start with the 3-point bend test. Now for this, I've got our very reliable Tunnux caramel wafer. Now these aren't available in selection boxes that I'm aware of, but these we use quite a lot again because you'll be able to find on the Discover Materials website that we have a paper about these. Something that we did over COVID, we sent all these out to prospective students from Sheffield, and we sent them 2. And we asked them to do an experiment because they couldn't come in and see us to do it. So we asked them to go and do it. So we did a 3-point bend test, and it literally is 3 points. So I don't know, I'm hoping you can see my camera there. So you're holding one end and pushing up from the middle. And that is basically a 3-point bend test. So these have been in the fridge. So they're a little bit tougher to break. There we go. Oh, making a mess all over my computer. And break sort of cleanish. I mean, it doesn't help that it's warmed up slightly. With them being colder, if they were colder, they would snap a little bit more effectively. But they are quite difficult to break. So that's sort of one experiment, a 3-point bend test. Now we can do that with a Tunnux, but we can also do it with something like a Whisper. So this is out of my selection box. And we're going to look at sort of Whisper back. So 3-point bend test on a Whisper. Again, quite tough, but oh, sorry. But a cleaner break. So if you look at the sort cross-sectional surface of a Whisper and a Tunnux, then you can see sort of the difference in the breaking. And we take that into consideration when we're looking at materials, how a laminated material would break differently to a solid material. So that's it in terms of a 3-point bend test. I'm going to move on to the torsion test now. So this is basically a twist test. So again, I'm using our Tunnux. And again, this is one of the things that we asked our students to do. So taking a Tunnux, and this time we're going to twist it. So twisting one hand clockwise and one hand anti-clockwise. We're going to twist it. Now this gets quite messy, so I'm going to try and cover up my laptop a little bit so I don't get quite as much messy on it with a bit of wrapping paper. And twist it. So that, again, this has been in the fridge, so it's slightly messier than it should be. There you go. Quite a mess. So lots of different sort of breaking surfaces there, very different from the snapping. So again, comparison, always good, looking at how it does it differently, how it works differently, and that tells us different properties. So again, taking my Whisper, I'm going to do the same with a Whisper. So this is out my selection box, and I'm going to do a torsion test. Now that one's quite nice. And now this is what happens with most solid materials. You can measure that degree angle, should be about 45 degrees. But again, a very different break to the one we had before. And this is why we do all these different tests, because various different materials behave in different ways, depending on what you do to them. So this is an example of that. 3-point bend test, twist test, torsion test, they're very different ways of breaking. And that tells us lots of different things about these materials. So the next thing I'm going to do is I'm going to do this tensile testing. So I'm going to just turn my laptop around here and show you our tensile testing machine. Now, as I said, you can borrow these from our different universities, and they are free to borrow. I'm hoping you can see that clearly. There is a reader, so you can set that to 0 and see how much strength it takes to separate these. So this is, again, out of our, not doing any advertising for Cadbury's really, but this is out of our selection box. So this is a fudge. Now, again, I've got ones at room temperature and ones at refrigerator temperature. Unfortunately, I took them out about 5 minutes ago, so they've warmed up a little bit. So I'm just going to pull that and slowly turning it. Now, this actually works better on a chomp, which is in the smaller ones. But hopefully you can see by pulling them apart. I don't know if you can see just down at the bottom, it's come apart there. So we can see where it's pulled apart and see how it's split. Now, unfortunately, with a fudge bar, it is where the clamps held it. Now, this worked better before. When you warm them up, now there's another possibility of changing the temperature. Warm it up slightly, see what happens when you hold it in your hand for a bit, see if you can warm it up a little bit, and that would make a difference in that respect. So again, using different materials, a chomp bar and mawam's really good for this. So we use mawams quite a lot, those little strips that you can use, flumps, even marshmallow types, using those to see the different properties from different materials in food form. So it's always handy, but like I say, you can have a real good try with things like that. The other thing I wanted to look at was something that we picked up from the Institute of Physics, was chocolate welding. So this is where the cup and the hot water comes into play. So I've got some boiling hot water here. I'm just going to pour into my mug and let that warm up a bit. So with this one, I would use I've had to do a bit of chocolate welding actually, the small bars of dairy milk, various different ones. And what you would need is 3 or 4 of those to make a girder. So I've got the 4th one here. And what you do for chocolate welding, you wait for your mug to warm up a little bit. And I have actually glass bottles that I use for this in schools, but a mug works just as well if you're doing it at home. So just press that chocolate bar against the warm mug, let it melt a little bit, so you've got a little bit of molten chocolate just down the side. Makes a lovely mess of your mugs. And put that together with another one, and so you are basically fixing those together. She says very effectively. So by doing that, and you need to leave that to set a little bit. I can do it with another one, and you're putting all four together and basically creating a girder. Now what you can do with that is then use that with the weights that I mentioned, however you want to use those weights or find them. You can use that to test how much weight this girder can take. And again, it's a great comparison tool because depending on how strong your welds are, so it could be just seeing who's the most effective welder in the class, or you could do it with a comparison of different materials, again, different chocolate bars. So I like to do Dairy Milk and Curly Wurlies are great ones as well, which are also available in the smaller selection box. So here we go. We've got our girder there. Oh, it needs to set a little bit, but we have our girder. I don't know if you can see that. That's our girder of welded chocolate. So we'd leave that to set, and then we go and test that between our two pillars. And the way I would do that is actually use the digital scales. So if you haven't got weights, this is another way of doing it. You can do a test on, so I'll put my two glasses on there, just making sure you can see that. Glasses on there and set that to 0, which is why it works better with digital scales. And for this one, I'm actually not going to use my girder. I'm going to use a crunchy. So here we are out of our, again, our selection box here. And again, I've got refrigerated ones and room temperature ones. And it's going to be difficult for me to do this at an elevator position. So I'm going to try and do it so I can do it here. So let's just make sure you can see this. So I'm going to set this to 0. And again, use it, as I said, using a comparison, going to press down in the middle. So this is sort of like a 3-point bend test. This might quite take a lot. So you're seeing how difficult this is, the frozen one. So it's going to take quite a lot to break it. But you can see how much effort it would take to break that. There you go. And somebody needs to keep an eye on the weight of that. So that's how we would use that. Basically, you can get some digital scales that would record that highest weight for you, but we use it sort of, somebody needs to keep an eye on that and see how much force it can take to break it. But that's another way of using these things at home. So that's the basic ones, using basic equipment. I've actually broken my welding now. That's typical. That's the way of using various different elements, things you can just find at home to do strength testing, chocolate welding, torsion testing, stretch tensile testing. I know I've used a tensile testing machine, but you pull them apart. As I mentioned, Mawams and Chomps are really good for that. And if you have a luggage weight carrier, sometimes that's really good to use for those sorts of things as well, because it records how that pulling strength as well. So just another thing that maybe you have at home that you could use, or even in the classroom. So how can we change this to make it sort of more adaptable, to increase the difficulty? Change the temperature, make it warmer, make it colder. As I mentioned, I've shown you some liquid nitrogen. I tend to put things in the freezer when I'm doing demonstrations. The school puts them in the freezer for me, so it's very easy for me to use various different temperatures. I don't take liquid nitrogen out to schools, but schools do come into us, and all the other members of the Discovered Materials group, and do experiments in the labs there. It definitely changes the properties of these various different chocolate bars. And the ones I like to use are things like the crunchy and things like a Twix. So where you've got caramel involved. So crunchy isn't affected by temperature. Why is that? Why is a Twix affected by temperature? What does happen to a Twix when it becomes colder? So that's one of the ones we increase the sort of the difficulty and the curiosity required and the thought processes that are required for the older students. Try different bars. There are lots. I mean, I've used maybe what is in there. There's 6 different bars in there. So there's a Whisper, a Crunchy, double decker. Can imagine how difficult a double decker is to break. So how difficult is that to break with a 3-point bend test? What happens to that when you cool the temperature down? Does it become more flexible? Does it become more brittle? Introducing words like that is really important for increasing that curiosity. And with the chocolate welding, as I've already mentioned, I tend to do the dairy milk. So take the bars, dairy milk bars and the curly whirlies and compare, see what the strength is with that. Is it, again, a temperature thing? So if your curly whirly is reduced in temperature, what happens to that caramel again? Does that affect how much weight it can take? So various different things that you can try at home with just a £1.35 selection box. So hopefully that's given you some ideas to go out there and try different things. As I say, chocolate is a marvelous material. We use it an awful lot with material science and engineering, but just taking that a little bit further with various different things you can find at home to just extend that experimentation side of things, and hopefully you can come up with various different things to do. Thank you very much.
Fantastic, Amanda. Thank you very much for that. It's really interesting stuff, and it's amazing sort of just how something lying around like chocolate, there's just so much science in there, and it's for some reason goes down very well when you sort of outreach events.
I'm covered in chocolate now.
Oh, fantastic. But yeah, it's all the sort of like science involved in those mechanical properties, like the sort of mouthfeel of a crunchy and sort of different fat contents of chocolate as well. It's an awful lot there. It's great.
And yes, and like I say, just £1.35 for a standard selection box. You get lots of different properties in there, so it's a great thing to do at home.